Hello and welcome to today's webinar. My name is Jeff Lyon. I lead technical operations for AWS WAF and AWS Shield. And I want to tell you about a couple of the services that you can use to build better security for your applications on AWS. As you move away from your applications that you traditionally hosted in on-premise data centers and start to think about security in the cloud, you may be wondering, how do I protect my application or prevent exploitation of vulnerabilities, or how do I mitigate distributed denial of service attacks? So we want to tell you a little bit more about those services. We're going to start by talking about AWS Shield. This is our DDoS mitigation product. And we'll also tell you about AWS WAF, which is a service that allows you to create your own rules to filter traffic inbound to your application. And while we tell you about these services, we're also going to have some demos to show you how they work and show you how you can use them for your individual use cases. So we'll talk about the major types of threats that you may be concerned about when you build your applications on AWS, specifically DDoS attacks, application attacks, and bad bots. I want to first focus on DDoS attacks. These are things like network and transport layer attacks and application layer attacks, or you may know them by their common names like reflection attacks. You may have heard of DNS reflection, SSDP reflection, and also those are types of amplification attacks, and also layer 4 floods like SYN floods. Other things you might be concerned about are SSL abuse, people trying to take advantage of how expensive SSL can be to process connections, and slow loris attacks, where an attacker looks to create and hold open connections to exhaust the capabilities of your application. And lastly, there's HTTP floods. This is where somebody makes a large volume of HTTP requests towards your application to try to exhaust the ability of your application to process those requests. So these are things that you can mitigate using AWS Shield. And some of the benefits of AWS Shield include full integration with AWS. This means that you can mitigate these attacks on AWS without having to route your traffic to any type of external network. You don't have to set up a new proxy or make any changes to BGP. These are all things that are handled for you by AWS. So when there's an attack, we're able to mitigate it on the wire at the point of ingress into the AWS network. Additionally, we provide you with always-on detection and mitigation. This means that as soon as we detect an attack, we're going to be able to mitigate it for you on your behalf. And there's not going to be a lot of additional latency overhead to process that attack and to keep your real valid users online. It's also affordable. We're not going to force you to make unnecessary trade-offs between cost and availability, because we want DDoS mitigation to be available for all AWS customers. And lastly, it's flexible. We're going to talk a little bit later about AWS WAF, which actually allows you to create your own rules so you can decide how traffic is mitigated and what types of connections or what types of requests are valid for your application. So AWS Shield comes in 2 tiers of protection. AWS Shield Standard is the standard tier of protection that's available to all AWS customers at no additional cost. So if you're using any AWS service in any region, there's nothing for you to do. You don't have to log into the console, you don't have to click any buttons, and you don't have to pay anything extra aside from what you already pay for cloud services. And then there's advanced protection. AWS Shield Advanced is a tier of service that provides you with additional protections, features, and benefits that allow you to see the different types of attacks that are coming in targeting your application, that allow you to request support, and I'll give you a whole bunch of other features that I'll discuss in a later slide here. So with AWS Shield Standard, you get automatic detection and mitigation for those layer 3 and 4 attacks. Like I mentioned, reflection attacks and SYN floods. These are things that when you build an application according to our best practices that we recommend, using services like CloudFront, Route 53, ELB, and ALB, are automatically mitigated. And that accounts for 96% of the most common attacks. Then for layer 7 attacks like HTTP floods, you have the AWS WAF. And this service is self-service and pay-as-you-go. So you're only paying for the web ACLs, the rules, and the requests that you process for your individual application and use case. So going over in better depth of some of the features that we offer for AWS Shield Advanced is you get additional detection and monitoring. So when there is an attack against your application, right there in the AWS Shield console, you're going to see an alert and be able to learn more about that attack that is targeting you. You'll get also CloudWatch metrics so that you can see the volume of attack and create alarms. And with a CloudWatch alarm, this allows you to send a notification to SNS and then subscribe other applications into that SNS topic. For example, you can integrate with third-party services like PagerDuty or Slack so that you or your operators can receive a notification when there's an attack in progress. You'll also receive protection against larger DDoS attacks. This means that with AWS Shield Advanced, when you're targeted by a very large flood, you can take advantage of the full surface area of the AWS global infrastructure to mitigate that attack using many different edge locations in many different regions that we offer. As mentioned, we provide you with visibility into the attack detection and mitigation. And while we do that, we're providing a very high rate of accuracy because we're baselining your individual traffic. So for your unique application or your unique use case, we keep that separate baseline. And when we see traffic that deviates, we're able to generate that alert for you. Then for the AWS WAF, if you're subscribed to AWS Shield Advanced, you receive that at no additional cost, so that a DDoS attack, specifically an HTTP flood, does not become an attack vector, or does not become an economic attack vector. So you're not actually having to pay for the fact that you're mitigating the attack. You also receive access to a 24/7 DDoS response team. So if you don't want to create your own rules, or if you just need additional help understanding the attack, or need an additional help placing new mitigations, you can call up the AWS DDoS response team and get very prompt assistance. And lastly, we provide you with cost protection. So not only is the AWS WAF at no additional cost, but if you notice that your AWS bill were to increase as the result of things like additional CloudFront request fees, additional Route 53 query charges, or the cost of scaling an ALB, you'll be able to reach out to us and request a refund of those charges. So AWS Shield Advanced today is available on 4 different services and in 4 AWS regions. It's available on Application Load Balancer, Classic Load Balancer, Amazon CloudFront, and Amazon Route 53. And the regions that we currently make available for you are Northern Virginia, Oregon, Ireland, and Tokyo. And so say that you're hosting an application outside of these regions. For example, say that you're in our Singapore region. You're actually able to use CloudFront and Route 53, which are global services, to receive all of the traffic on behalf of your application, mitigate the attacks, and it doesn't matter if the application itself is hosted in an AWS region where Shield Advanced is available. So now I'd like to hand the webinar over to Sundar, who will tell us more about AWS WAF.
So the next section of the Tech Talk today will deep dive into the AWS Web Application Firewall. This also includes 3 demonstrations that we'll be doing to cover whitelisting of users for positive security model. We'll also do a demo on how to use AWS WAF for virtual patching. And we'll end it by doing the last demo, which is how would one prevent a brute force attack on a login page, for example. To get started, so like Jeff alluded to before, with the type of threats we see on layer 7 that we can use AWS WAF to protect, we broadly categorize them into 3 sections. The first one is the DDoS, where you have HTTP floods, where you have increased number of requests, overwhelming number of requests coming from a botnet, trying to bring down the availability of application. The second category is the application vulnerabilities, more popularly known as the OWASP top 10 kind of vulnerabilities. So you could use AWS WAF to write rules against SQLi injection and cross-site scripting today. And you can also make available some of the templates that we recently released to give you protections against some of the other categories in the OWASP top 10. The last category is bad bots and scrapers. So this is a very big problem customers have come to us that have asked us to solve. So with bad bots, it could be anything like content scrapers or bots that are trying to steal either images or pricing information, things like that from your web assets. So we will show you how you can protect yourself using AWS WAF. So what is AWS WAF? We can describe this service along three fronts. Primarily, it provides you the ability to write custom rules that will allow you to write filters of what you can allow and what you can block. We support 5 different types of conditions where you can block based on IP addresses. You can block based on specific string matches that you see in any part of your HTTP or HTTPS request. We allow you the flexibility to stop or count or block based on the size of the different portions of the HTTP request, and so on and so forth, which I will show you more during the demos. The second is so the first one with the filtering, you can actually apply either a positive security model or a negative security model, or you can put a rule in count mode where you can just observe certain type of traffics and put them on a kind of a watch list. So that's really the benefit of web traffic filtering. With malicious request blocking, this is when you absolutely are certain what to block. So we provide SQLi injection and cross-site scripting. These are 2 protections that are natively provided for you within AWS WAF. If, for example, you deem certain user agents to be malicious, you can write a very simple rule and put that rule into a block mode. And that way you can block malicious requests from entering your web applications. The last but not the least is active monitoring and tuning. AWS WAF provides you dashboards. It provides you sample requests, and also is integrated with CloudWatch metrics, where you can set up alarms on CloudWatch metrics to alert yourself when certain traffic is seen, especially the ones that are in count mode. All the benefits of CloudWatch metrics are available to you. For example, you can subscribe either a notification like an SNS topic to an alarm. You can text yourself by subscribing an SMS topic to the alarm, or you can be a little more sophisticated and actually execute a Lambda function when the CloudWatch alarm goes off. So let's talk about some of the key benefits of AWS WAF as we've heard from AWS WAF users today. The first and foremost that we hear is the ease of use. Today, AWS WAF sits in front of CloudFront as well as application load balancers. So these 2 services are the 2 major public endpoints that we see on AWS WAF. And the fact that you can, with a few clicks, deploy an AWS WAF on these public endpoints makes it really very easy and flexible for customers to use a web application firewall. You do not have to maintain your EC2 instances. You do not have to scale them, nor do you have to architect a VPC architecture, which you would have to if you were to deploy an RV-based WAF or any other WAFs. So we've made it really easy for you to include AWS WAF into your architecture. With the ease of use, you also do not have to share your SSL certs because the underlying service, either the application load balancer or the CloudFront, takes care of that for you. So by including a WAF, the additional overhead of SSL cert sharing is eliminated. Fast incident response is another feature that customers have come to like. We have a P99 of about 55 seconds from the time you hit a submit button on a rule update or a new rule. All your global assets, it could be application load balancers running in the different regions that WAF is available in, as well as all 80 CloudFront POPs that are there globally today. So all your global assets will get the new update of the new rule within 55 seconds. The normal time is more along the lines of 15 to 25 seconds. So this is for customers who say, I want to be able to update the rules not in an hour, not in a day, but within a minute. So you have that with AWS WAF. This is especially useful when you're under a DDoS or any kind of an attack where you know who the attacker is, either you know some attribute in the request or you know the IP address. This allows you to write a rule and get that rule out to all your globally within under a minute. We also have an inspection time that is less than 1 millisecond for those who are concerned with latency of having WAF in line with the web request. So we have a latency of less than 1 milliseconds. The third thing that we've really heard from customers, especially the DevOps shops, customers who are looking to implement DevSecOps, where they want to combine the application development and application deployment with security. We have provided 100% APIs and also a very flexible rule language that allows you to write custom rules. This is one of the main motivations for us to take on AWS WAF as a project, is to be able to kind of combine it with other AWS services and also give a 100% software controllability. Last but not the least, customers have come to like the flexible rule language, but they've also said, hey, how about giving us some pre-configured protections or checkbox solutions, some kind of rules that's available right out of the box. So for that, we have released a couple of different templates. September last year, we released a template that protects you against common protections, such as bad bots, HTTP floods, IP reputational lists. And earlier this month, we actually launched another template that gives you that provides you sample rules to protect yourselves against the OWASP top 10 type attacks. So how does AWS WAF protect you? So we call this the pyramid of security. At the very bottom, you have the flexible rule language. If you were to start with a bare-bone AWS WAF, you have a very easily a flexible rule language that's very easy to understand and write. These are specifically for your custom rules. Built on top of the flexible rule language are pre-configured protections that I alluded to before, that we have provided in the form of CloudFormation templates that can be deployed within a matter of minutes. As you move up the pyramid, you get a little more sophisticated. The use cases get a little more complex. So with security automations, AWS WAF, you utilize the capabilities of AWS WAF in integration with other AWS services such as Lambda and API Gateway and CloudWatch to implement some of the use cases you might have. For example, Mapbox is an AWS WAF user that use AWS WAF primarily for mitigation purposes. They have upstream systems that can actually detect bad bots. They have their own logic, and they use AWS WAF and its 100% API capability to plug in rule updates in a closed loop fashion with no manual intervention or with no engineers involved. And I will talk a little bit more about security automations when I talk about some of the popular use cases that customers use AWS WAF for. Here are some common protections that customers use AWS WAF today for. We have protections against IP reputational lists. This is a use case where we provide the solution, again, through the CloudFormation template that you can deploy. In this solution, we actually download an IP reputational list, a list of bad actors out there from 3 different sources, and we plug them into WAF as a rule that's readily available for you. With the recently launched rate-based rules, we've also implemented protections against HTTP floods, where you can actually limit the number of requests coming per client in a 5-minute bucket. So if you deem anything more than 3,000 requests in a 5-minute is deemed as an HTTP flood, or you want to control each client's request rate below that, you can set up a rate-based rule today very easily to be able to block those high request rates. With bots and scrapers, our solution is a very unique one in the sense we use the concept of honeypot URL. Again, this solution is again available through the pre-configured templates that's available to you, that we will share the links with you later on. With the honeypot URL, we allow customers to embed a URL into their websites that is not visible on the browser. And we publish this honeypot URL into the robot.txt. So any good bot that's allowed honors the robot.txt. The first thing that it establishes is a download of the robot.txt. And in the robot.txt, you have resources that the bots are allowed to access, and there are resources of the bots that are out of bounds to the bots. and the honeypot URL will be indicated as a disallow or do not access. Obviously, the bad bots do not honor the robot.txt, and they would access this URL. And we would use, the URL has an API gateway endpoint, and as soon as a bot accesses this URL, for example, the API gateway extracts, the API gateway endpoint launches a Lambda function and extracts the IP address of that bad bot and plugs it into WAF as a blacklisted IP address automatically without you having to do anything. Those are some of the popular use cases today. I don't think I'll be going into each one of them in detail. I covered a couple of the more important ones. This just allows us more time for the demo. So we have 3 demos today. The first one, I will be demoing how to whitelist good users. In this case, the use case is a use case where I only want to allow requests coming in from a particular referrer. The second demo I'll be doing is how to use AWS WAF for virtual patching. And the third demo would be will show you how you can prevent a brute force attack on the login page of your web applications. So with the first demo, what you see on the left is what the raw request looks like. What we are specifically interested is the link from which your application was accessed from, which is available to you on the HTTP header, the referrer portion of the HTTP header. And this example, we will whitelist any traffic coming from the site www.example.com. On the right is how the AWS WAF rule looks like. What we say here is we will set up a rule that will look at the header portion, the referrer portion on the header, and we will write contains matching string match rule to allow those traffic only. Anything else will be blocked. In this example, we're showing AWS WAF deployed on a CloudFront. So when requests are sent to AWS WAF, it either says A or nay, and depending on the signal that the AWS WAF sends CloudFront, it either blocks the traffic. So for our first demo, I'm going to spend just a little bit of time just going over how a rule is written on AWS WAF. We have 3 basic components. What we have is conditions. We allow 3 types of conditions. For the whitelisting, we will be using a string match condition. When you have the condition written, you attach the condition to a rule, and then you attach a rule to a webACL. And webACL is really the entity that you will associate with a resource like an application load balancer resource or a CloudFront distribution resource. So let's get started. The first thing we're going to do is write a string match condition. And here I've just picked Tokyo as the region. So the first thing is we give it a name. I'll just call it test whitelisting. And the region is Tokyo. And like I said in the presentation deck earlier, you need to pick which portion of the HTTP request you're interested in looking at or inspecting. In this case, we're trying to whitelist referrers, which is in the header. And we will scroll down to the referrer. Anything in the scroll down list here are standard headers, and anything that's non-standard like X forwarded for, etc., can actually be typed into the header field. In this case, we're trying to do contains. Anything that contains the referral link will be applied. In terms of the transformation, this is for transformations we allow things like convert to lowercase, and if anything is HTML or URL encoded, we allow you to decode them. In this case, it's a simple convert to lowercase just to make sure there's no obfuscation, just to cover all the camel notations of the uppercase and lowercase. So it's as simple as that. We add the filter, and what we have is a reference contains example.com. All we do is hit create. In case you're not very sure of whether you need a different kind of transformation, it's as simple as creating another filter, going to the referrer, and if you don't want contains and you want to do a starts with or an exact match, you can do that as well. And in this case, I will do a node transformation, for example, and I will type in example.com, which is what the value we're trying to map. And what we have here is two different filters, and the two filters are ORed within this condition. If any one of them match, you will have that particular condition firing. So while we wait for that to create, the next step, so you have test whitelisting there. The next thing we need to do is create a role. Again, it has to be in the same region as Tokyo. So I'll just call it test whitelisting rule. We have two types of rules, a regular rule, and as of June, we released a new rule type called the rate-based rule. In this case, this is a simple regular rule. And in this case, we need to add the conditions. So every rule has conditions. You can add multiple conditions within a rule, and all the conditions are added within a rule. In this case, we have just one condition, which is when it does match an IP string condition that we just created, and it's called test whitelisting. And I hit create. So what this does is adds the whitelisting condition that we created into the rule. There you go. We have the test whitelisting rule that we are going to now create a webACL for and attach that rule into that webACL. I'm just going to call this webACL. Again, this webACL is the entity that you actually attach the resource you're trying to protect, either an ALB or a CloudFront distribution. I currently don't have any resources in Tokyo, unfortunately. Otherwise, you will have a drop down of either your ALBs and your CloudFront distributions here, and you can select which ones you would like to associate that webACL with. This is a description of how you want to create the different conditions that I walked you through. And here, this is your chance to actually apply that particular rule to the webACL. In this case, since this is a whitelisting rule, the default action for that particular webACL should be block all other requests that don't match any of these rules, because you want to allow only traffic coming from the referrer link with example.com. So what we do here is review and create. You just review your configurations, confirm and create. It's that simple. So within a matter of minutes, we were able to create a string match condition to match the referrer. We created a rule and a webACL, and the webACL defaults to a block all requests except that whitelisting request. So with that, now let's look at the second demo. So with the second demo, virtual patching is another use case that customers have asked us to solve. Virtual patching is a concept where you're using firewalls to protect your web assets and your web applications that buys you time while you're actually fixing your application code, testing it, and deploying it. In this case, in this virtual patching use case, what we'll do is we'll take the Apache Struts vulnerability that came out earlier this year. We actually put out a blog post on how you can write a rule within a minute to actually protect your web applications from this particular vulnerability. So let's look at the second demo. So with the second demo, I'm going to use the same webACL. That way we don't have to create a new one. But what we do have to create is a string match condition. The Apache Struts vulnerability manifests itself in the content type in the header, and there's a specific string match that we will apply to prevent that particular attack. Again, what we do here is create another string match condition. I'll just call this Apache Struts example. Again, it's going to be in the Tokyo region because that's where we're doing the demo. And we're looking at the header again. And in the header is the content type, where this attack manifests itself. The content type in the header is the portion that actually gives you the MIME type for the body of the request, usually in your post and push put requests. And the match type could either be contains or exact matches. Let's make it very generic. Contains. The transformation, again, we will do a lowercase transformation to prevent any camel notation obfuscation. And Looking at the CVE, all you have to do is put in the string hash command equals, and that's all it takes. Anytime there is hash command equals in the content type of the header, that would be a Apache Strut manifestation of the Apache Struts vulnerability attack. So we add that filter, and what we have is a string match condition that looks at the content type in the header and matches it against hash command equals. We hit create button, and with that you've created the string match condition that you have to apply to a rule, just like we did for the whitelisting. Again, we'll create a rule type here. Tokyo, this is a regular rule again, and what we do here is when it does match the string match condition, and in this case the Apache Strut example, the purpose of the rule is really there are a few attributes of the rule that's not available in the condition. That's the reason you have the rule. In a rule you can actually pick between three actions. You can either block based on the matches on that rule, you can allow if that rule is a whitelisting rule like we saw with the whitelisting rule, or you can put it in account mode, which is R mode for learning. Okay, so with that, let's move on to the third demo. So the last demo we have for today is how to use AWS WAF to do a brute force login attempt prevention. So in this, we actually use a rate-based rule. We combine it with a string match condition on the URI, and with that, we actually get protections against. You can actually limit the number of access to the login page and actually blacklist the client that goes over that particular limit. With that, let's look at the demo. So I'm going to create a rule here. This is, I'm just going to call it a brute force example. Actually, before that, we need to create, we actually need to create a string match condition that will apply to the rule. And this would be a login page. String match condition. What we do here is we look at the URI portion of the request and we say it starts with, or it could be contains. The transformation again is a lowercase transformation, and anything that has this could be anything that you have configured in as the URI for the login page. So just to keep it simple, we'll just call it /login. This is what follows your domain name. We would add the filter. So this would actually filter or recognize all requests with the URI starting with /login. So we would then use the string match condition to filter the HTTP requests that are being counted in your rate-based role. Next, we go create a rate-based role for brute force login. And this is the difference. This is different from the. This is actually a rate-based role, so we'll pick rate-based role, and let's set the limit at maybe 2,000. So 2,000 requests per 5-minute bucket. That roughly translates to about 6.6 RPS. So if you want a higher rate, you can put it in there. So let's go with 2,000 for now. So if you don't add any conditions to the rate-based role, it counts all the requests coming from that particular client. In this case, we don't want to count all the requests. We want only requests that are targeted to the login page, and that's the reason we created the string match condition on the URI page. So we would pick to filter the requests that are being counted towards the rate-based role. We will pick the string match condition that we created on the login page that actually looks at the URI with /login, and we hit the create. So this blocks all requests coming from a particular client, a particular IP that goes beyond 2,000 requests per 5-minute bucket, roughly translating to 6 to 7 RPS on the login page. So that completes the 3 rules. We can go to the web ACL and actually assign those rules that we created. And I'm going to just hit the edit webACL, and we will assign all the 3 rules that we created in the 3 demos. This will also show you that you can actually stack rank the rules in the priority order. In this case, since the whitelisting rule would be recommended to be the last rule that gets implemented, because if there is an Apache attack, Apache Struts vulnerability attack, or your brute force attack, you want them dropped off before it actually gets to the whitelisting rule. Since the whitelisting rule would be, since it's a whitelisting rule, the action is allowed. For the brute force login, it's a block, and for the Apache Strut, it's a block. So with that, you've applied all the 3 rules that we've created. The first one to whitelist users, the second one for virtual patching against a major CVE that came out earlier this year, and the third one is to prevent a brute force attack on your login page. With that, we've completed the 3 demos. So lastly, I'd like to conclude by a call to action. Please take a look at the white paper that we recently released on how you can use AWS WAF against the OWASP top 10 vulnerabilities. The white paper also comes with a detailed, it also comes with a CloudFormation template that you can very easily deploy. That actually applies and write those sample rules that I mentioned